This is a look at another Pivot Interactive, all about choosing the right indicator. So as part of the acid-base chemistry unit, students have to generate a titration curve, and there is a science and motion lab for that. This is an interesting take on that because it's having them choose the right indicator just based on experimentation. So this gives you some data that you can analyze and that the students can analyze. And I'm going to add something different to it at the end. So let's jump right in. So this is the pH sensor. The vernier sensors are the same ones that are used by Science in Motion. And we're just going to let it play. They add the acid. It starts to come in. And then we jump to the end. So notice that you can go back and forth and record the pH at any volume of the base. Then it has you collect, and I just collected some sample data. I made one column, the milliliters of base. This is going to be that x-axis, and the pH being the y-axis. I just collected data right from the video itself. You could do that. And then as you scroll down, you'll notice it generates kind of a titration curve here. And then you can also come in here and say, I want a different one. I want the weak base and strong acid. And you can also change the indicator. And then you can collect data for this titration. The idea is you should be monitoring not only the color and the pH, but you should also be looking at the titration curve and noticing when do you see that huge change in the titration curve. So my graph is not complete. I would want to go in and fill out some of these points in here, and this would give me some idea of where the equivalence point is. So you will finish out the graph. And then you have to make a choice and defend it with phenolphthalein. Is that best for the first reaction or the second reaction? So this is very much like you would see in an AP style question. Same thing for bromocresol green. And then you could look at this last question and explain how you would pick an indicator. Now what I would have you do to add to this is, let's go back and look at the curve that you generate. Find that point where it's the half equivalence point, and that's where pH is equal to pKa. So you ought to be able to go through there and find out which acid or base they're using, right? So if you find that the pKa is a given value, you could look up in a table of acids the pKa for that, and then you could go, aha, now I know what that acid is. So this would be an extension of this. You could also look up the pKa of the indicator itself. So you'd want to go up and look up the pKa of bromocresol green and the pKa of phenolphthalein. The pKa of the indicator needs to be very close to the pH at the equivalence point. So this is a good way for students to look at data and make some decisions. All right, so your turn. Let's go out and do the acid-base titrations choosing the right indicator.